Look at the interesting topic of transformation of roots of a polynomial equation. So let us take an example and see what we are trying to do in this topic. So let us take an example. So if you have an equation x square minus 5x plus 6 is equal to 0. So let us take a very simple quadratic equation. X square minus 5x plus 6 is equal to 0. So the roots of this equation, as we know, are 2 and 3, because this is x minus 2 into x minus 3 is equal to 0. Now let us say that you're asked to find an equation, you're asked to find a quadratic equation whose roots are double the roots of this equation. You're asked to find a quadratic equation whose roots are double the roots of this equation, that is 4 and 6. So how do we find the equation? So the process is like this. Okay, the roots of this equation, let us say that the roots are alpha comma beta. Now I want the equation whose roots are 2 alpha and 2 beta. So let us take a variable y is equal to 2x. Let us take a variable y is equal to 2x. So let us say that x is a root of this equation. Let us say that x is a root of this equation. Now I want an equation whose roots are y, because y is equal to 2x. So if x is a root of this equation, I want an equation whose roots are y. That means I want a condition which y satisfies. Specifically, I want a quadratic condition which y satisfies. So to find that is very easy. So let us see how to do this. So y is equal to 2x. This implies x is equal to y by 2. And my x is a solution to this equation. That means this y by 2 satisfies this equation. So let us put y by 2 in the place of x. So you get y by 2 whole square minus 5 times y by 2 plus 6 is equal to 0. This implies y square by 4 minus 5y by 2 plus 6 is equal to 0. This implies y square minus 10y plus 24 is equal to 0. So this is a quadratic condition which y satisfies, and y is nothing but 2 times the number which satisfies this equation. Hence this is an equation whose roots are 2 alpha and 2 beta. So if you want an equation in x, finally you can put x in the place of y. So x square minus 10x plus 24 is equal to 0 is an equation whose roots are 2 times 2 and 2 times 3, that is 4 and 6. You can check for yourself. So this is nothing but x minus 4 times x minus 6, right? So the roots are 4 and 6, which you are asked to find. So effectively, what have you done? So if you want an equation whose roots are 2 times the roots of the original equation, you just need to put y by 2 in the place of x. That is the reverse of that. If you want the roots to be double, you have to put y by 2 in the place of x. If you want the roots to be triple, so the condition, if you want the roots to be triple, so we take y is equal to 3x and x is equal to y by 3. So if you want the roots to be 3 times, you have to put x is equal to y by 3. So this is a general process in which we transform the roots. So let us take another example. X cube minus 3x square plus 5x plus 2 is equal to 0. So this is a cubic equation. Let the roots of this equation be alpha, beta and gamma. Let the roots of this equation be alpha, beta and gamma. Now I want an equation, a cubic equation, whose roots are 2 greater than the roots of this equation. It means I want an equation whose roots are alpha plus 2, beta plus 2 and gamma plus 2. I want to increase the magnitude of the roots by 2 units. So how do I do it? So again, let us say that x is a solution to this equation. Now I want, so let me say y is equal to x plus 2. So x is a root of this equation. I want an equation whose roots are y. That is, I want a cubic condition which y satisfies. So how do I get this? So y is equal to x plus 2 implies x is equal to y minus 2. X is equal to y minus 2. So let us put x is equal to y minus 2 in here. So y minus 2 whole cube minus 3 times y minus 2 whole square plus 5 times y minus 2 plus 2 is equal to 0. So you just need to expand this. So y cube minus 3y square times 2, that is 6y square plus 3 into 2 square, 3 4s are 12y minus 8 minus 3y square plus 12y minus 12 plus 5y minus 10 plus 2 is equal to 0. This implies y cube minus 6y square minus 3y square is minus 9y square. 24y plus 9y plus 5y, that is 29y. 8 minus 20 minus 30 plus 2 is minus 28 is equal to 0. So this is a condition in y, and y is nothing but x plus 2. That means if x is a root of this, x plus 2 will be a root of this. So this is an equation whose roots are 2 greater than the roots of this equation. So I hope you understand what we are doing. We are just substituting the reverse function in the place of x. So if you want the roots to be greater by 2, you have to substitute y minus 2. If you want the roots to be lesser by 2, you have to substitute y plus 2 in the place of x, so on. So let us take some standard transformations and see the substitutions that you need to do to get the required transformations. So let us look at some standard transformations and the standard substitutions that need to be done so that we get the transformations. So first, if you have an original equation whose roots are alpha, beta, so on. Now, if I want my roots to be transformed to some k times alpha, k times beta, so on. That means if I want my roots to be multiplied or divided by some number. So if you want to multiply the roots by some number, the substitution that you need to do is y by k in the place of x. So if you want to multiply by 2, you have to write y by 2. If you want to multiply by 3, you have to write y by 3. If you want to multiply by 1 by 3, that is, if you want to divide by 3, you have to multiply by 3 here. So whatever you do here, you have to do the opposite when you do the substitution. Next, when you want to add certain number to all the roots, if you want to increase the magnitude of all the roots by a number k, you have to substitute y minus k in the place of x. Y minus k in the place of x. Next, if you want to raise all the roots to some power n, you have to substitute nth root of y in the place of x. Because y is equal to x power n implies x is equal to nth root of y. Next, if you want the roots to be reciprocals of the original roots, y is equal to 1 by x. This implies x is equal to 1 by y. So you need to substitute 1 by y in the place of x. If you want the roots to be of negative signs of the original roots, so y is equal to minus x implies x is equal to minus y, right? So you just need to put minus y in the place of x. So these are some very standard substitutions. That leads to very standard transformations. So if you have some complicated transformations, you just need to use this process. Whatever is the transformation, you need to write y is equal to some sort of transformation in x. And you have to find what x is in terms of y. And you need to substitute this in the place of x. So let us take some more examples. So let us take this example. X cube minus 5x square plus 2x minus 3 is equal to 0 has roots alpha, beta and gamma. You're asked to find the equation whose roots are alpha by 1 plus alpha, beta by 1 plus beta and gamma by 1 plus gamma. So how do we transform the original roots into these roots? So as you can very clearly see, the transformation, if this number is x, the transformation is of the form x by 1 plus x, is same for all the roots. So you have to have the same transformation for all the roots. Then only we can use the theory of transformation of roots. So let us take y is equal to x by 1 plus x. So if x is a root of this equation, you want an equation whose roots are of the form x by 1 plus x. So y is equal to x by 1 plus x. I want a condition, cubic condition in y. So this implies y plus xy is equal to x. I'll try to find what x is. This implies y is equal to x minus xy. That is equal to x times 1 minus y. And this implies x is equal to y by 1 minus y. So if y is equal to x by 1 plus x, x has to be equal to y by 1 minus y. But we know that x satisfies this equation. This implies y by 1 minus y whole cube minus 5 times y by 1 minus y whole square plus 2 times y by 1 minus y minus 3 is equal to 0. Y by 1 minus y whole cube minus 5 times y by 1 minus y whole square plus 2 times y by 1 minus y minus 3 is equal to 0. So this is the required equation in y whose roots are these three. Now we just need to simplify these roots. So let us take the LCM. So you get y cube minus 5y square times 1 minus y plus 2y times 1 minus y whole square minus 3 times 1 minus y whole cube is equal to 0. So you just need to simplify and collect the terms. Y cube minus 5y square plus 5y cube plus 2y cube plus 2y minus 4y square minus 3 plus 3y cube minus 3y, so plus 9y minus 9y square is equal to 0. So you just need to collect the terms y cube, 5y cube, 2y cube, 3y cube. So 7, 10, 11. So 11y cube and minus 5y square minus 4y square minus 9y square minus 9y square is minus 18y square. So these three are completed. So 9y plus 2y is 11y. 9y plus 2y is 11y. And minus 3 is equal to 0. So this is the required equation.